So what is the relationship or the correlation between the soil and then the bacteria or the sewage? Because I think that it's so important to understand that we're testing sewage water after a main break.
Yeah, so when water has contact with soil, it becomes classified as Category 3 black water. And what that means is it's treated essentially as sewage water. Sewage bacteria are naturally occurring. They're in the soil. You know, unless you're going outside and eating a bunch of dirt, it's generally not a problem. My toddler's eaten their fair share of dirt. So listen, it happens. But that being said, when that naturally occurring bacteria ends up in the soil, and then that soil ends up in the water, that can lead to problems because then that's something that is intended for human ingestion.
The idea is to discuss with you, first of all, I know that you and me have different fields in the environmental work. Okay, I work tremendously with remediation, abatement, and repairing, and you work a lot with testing. So the first thing to do, testing, analysis, design, I mean, you name it, with a lot of stuff that happened before I come in. But then let's discuss about water. Okay, water is a very complex subject, and I thought it was even simpler, and then when I talked to you, it made it really complicated. Why do you think we should test for water?
Well, I like to know what I'm drinking. I like to know what I'm ingesting. And to me, it's important to know what's in that for my health, for my family's health, for the health of everybody, you know, that drinks water, which is all of us, except for the people that survive on coffee alone.
Okay, so coffee is safer than water?
Well, it's still based on water, right?
Okay. Going on that flow, so you have some medical reasons why you have to test water, which I think are very important for everybody that is watching or hearing this podcast, is that in reality, the medical reasons, not only they're acute, they happen very fast, but they create the worst organ damage or any type of condition. What can you tell us about medical problems or biological problems in water?
Well, they can be chronic or acute. They can happen quickly, quick onset, or it can go, you know, you're drinking the same thing at low levels for decades of your life, you know, whatever you've got at your house. But, you know, the thing is, let's say that you're ingesting a ton of water from Flint, Michigan, that has a lot of lead in it. Well, that's going to be a big problem for the developing babies that are there, getting their bottles made from that.
100%.
That can be a big problem for, you know, the pregnant women who are drinking that water. It's just something that can be both chronic and acute. It can happen right there, or it can happen over a long time.
Okay. So then the type of water contamination, let's talk about, because I think there are three main categories that we had discussed in previous discussions, literally. So we have like a chemical problem, then we have like a soil issue, and then finally we have this biological issue, okay? I don't know if we should go back to biological, but let's see the difference between the biological and the soil or the chemical. Which one do you think poses the greatest problem in our communities?
Well, I think the biological and the soil are interrelated. When you end up with, let's say, a pipe break and soil gets into the water, that soil can have naturally occurring bacteria in it. So then you can end up with that bacteria in the water. Not everything natural is good and healthy for us, right? Like we like to think, oh, it's all natural. I'm going to get that bag from the store because it's all natural. Well, lead's natural. Fecal bacteria are natural. Doesn't mean I want to drink it. And it can lead to health ramifications down the line.
Okay. So summarizing the two tests that I think, and you told me they could be important, what will be one test, and why do we have all these battles here, but what will be one test that will test the biological problem, and one test that will test the lead.
Yeah. Total coliform would be what I would do for just general biologics. Do I have some kind of sewage contamination, whether it came from the soil, whether it came from some kind of pipe issue? You can run a total coliform test, and that, let's see, be right here. So you would just fill up a bottle from the lab using proper procedures, and then send it off, and that would give you a really good indication as to whether there was bacterial contamination in your water.
Is this something that people can do on their own? Because for some of the work I do, when we do after the fact testing or whatever, homeowner test is very inaccurate. I mean, we have multiple issues with that. Is there a difference between a homeowner test or a lab test?
Yeah. The laboratories are accredited and certified as to meeting a whole range of criteria that prove that they're going to get the same result every single time they test the same thing. So if they know, in their calibration, for instance, if they have a source that they know contains 5 milligrams per liter of a contaminant, when they run it in the lab, they're going to get a 5 answer.
Okay.
The homeowner tests, unfortunately, what you can get off Amazon, those are not quite so accurate. You might know that it's a 5 that you're getting tested. It might turn out to be anywhere from 2 to 50.
And do you think the homeowner also, because lack of expertise, could them contaminate samples or no collect the right amount, or are there any other failure points?
Yeah, for sure. I mean, that's why I've got the gloves here. If you're not wearing the correct gloves, your own skin could contaminate it. Or some of these bottles have an acid preservative in them. You don't want that on your skin. You'll end up getting burned.
Okay.
So, unfortunately, not collecting in the right way can end up causing a sample that's useless. You can't rely on the results at all.
Okay, and in big cities where they are city water supplied, is there a need for testing? And then we contrast that to homes or farms that are in well water. Is there a contrast between the two?
Sure. So public supplied water, municipal supplied water, they are required to test on a routine basis for a list of contaminants that's pages and pages long. Everything you could think of, from radioactive stuff to bacteria to metals, disinfection byproducts, whatever you could think of. They have to test for those things on a regular and routine basis. And then they have to provide those results to the public. Usually they do it on their website, but basically if you want those results, you can look at them. If you're on well water, nobody's doing that for you unless you're doing it yourself. Okay. So in that case, you have to take that into your own hands and contact somebody that can help you with that testing.
So if people are buying a house in well water, it's very recommended that they do their own test. When you buy a house in public water, maybe you can read the results. Yeah. Now, that being said, I have seen some results where they are actually exempt from testing, and we don't know how this happens, and I don't know who made the decision to exempt municipalities to do testing, but I've seen it happening mostly with asbestos, and I guess the same thing as for lead. Yeah. Now, after a break or something like that, clumps of these materials can be injected into the water system, and they can travel, like I say again, in clumps, so they can then stick together to go from place to place. And we're going back to the testing of these materials, because you say lead is also very important. So we already know the testing for biological or coliforms, it has to be done hopefully by a professional in a lab that can do it right. Okay, what about lead?
Same thing. You want to use a certified lab. You want to have a professional do that sampling. If you're not collecting what's called the first draw, you're not getting an accurate result. So there's a certain amount of time that you want the water to sit in the pipes undisturbed before you take that sample. And you don't want it to be too long or too short of a time that it's sat there. So helping design when we collect these samples is sometimes just as important as how we collect them. So again, I would go to a professional to get it tested. That being said, even if you're on public water, sometimes you might want to do your own testing. Maybe you've had a plumbing issue at your own home. Maybe you know that there's something funky going on.
There are buildings that have been inhabited or renovated or empty for 40 years, then rehabilitated, and many of these plumbing is no change, okay? Because the materials used in plumbing, lead, brass or copper, stuff like that, these type of materials have a really long lasting life. That being said, it doesn't mean that bacteria and other things don't grow inside these pipes that can then contaminate the water. So whenever we look at this type of situation, do you recommend that some buildings and some homes do some periodic testing?
It's always a good idea. I mean, more data is good data, right? So if you have the means to do it, collecting those samples and getting them analyzed is great. It can be pricey. It can take a little bit of time to find somebody that's able to do that for you, but it's always a good idea to get it tested.
Okay. You mentioned something one day we were at lunch about if you can, like the stuff that we work with, you cannot really see it, you cannot really smell it. So what would be the only way to know?
You got to test. I mean, you won't know unless you test. There's no odor to a lot of these things. There's no color. That being said, if you open your faucet and it starts coming out like orange water, maybe get that checked out. There's probably something going on. But yeah, I mean, there's been water that's clear as day that has issues, and you just don't know unless you run a test.
Okay. So based on this main water break, we can summarize that it's important to do a coliforms by a lab, and then after that some heavy metal like lead. If you can remind me, what is the easiest and more efficient lead test in water?
You got to send it to a lab. There's no like paper that you can put in there that has a color change or anything. You got to send it to a lab.
Okay. So all these things that people have that you put little drips for measuring chlorine or other strips, what are they good for?
They're good for screening. If you like with your pool, you put a little water in here, you put a little water in there, you add the colors, you test the strips, and it's all to get a general idea, a range. Hey, do I have a problem or not? But it's not going to give you a specific level. If that kind of thing's out there for lead in water, it's not going to be relied upon by an accredited lab, for instance. Okay. You're going to have to send it to a lab to get that information.
And then I have this other sample here. What is this one used for?
So Legionella.
Okay.
We haven't really brought that up at all.
Okay. So let's go ahead. Why are we testing for Legionella right now?
All right. So another bacteria that's out there, again, naturally occurring, is Legionella. It's a bacteria that occurs naturally all over the place, but it grows and reproduces when it's in warm temperatures in water. Well, humans also like warm water.
Okay.
Showers, spas, hot tubs, all of that can be an area that Legionella can occur. Unfortunately, another one is cooling towers. So in commercial spaces, commercial buildings, we oftentimes use cooling towers to air condition the space. That's a way that we are cooling throughout the building on a more efficient scale. That water goes through cycles of heating and cooling, but the cooling is only getting it down to room temperature, maybe. It's still staying very warm. So the bacteria is like having a party in there. If it gets in, it's reproducing. Well, in the inside of pipes, we always think they're smooth, but they're very much not unless they're brand new. They have a big surface area, lots of nooks and crannies that stuff likes to hide out in, like bacteria can form a film on the inside of the pipe, and then you've got this nice gooey layer of bacteria soup that we call biofilm. When we go and we suspect that there might be a biofilm buildup in a system, we might use the swab to sample that discoloration, and then we'll culture that in a lab to see what grows. Is it Legionella or is it some other type of bacteria that doesn't have the health ramifications that Legionella does?
But then what about from the water supplies? Because, I mean, you're talking about these chillers and all these other water towers being now fed water from the water supply that can somehow increase the amount of bacteria that gets into these towers.
Yeah, so Legionella is one of those things that potable water suppliers are supposed to be testing for, and many of them do on a regular basis. But because it's naturally occurring, let's say that there's a break, Legionella can enter the system after the water treatment plant treatment has occurred. Or in cooling tower systems, because that water is recirculated, anything that gets in there has more of a chance to continue growing and reproducing in that system, especially because it's a nice warm home for the bacteria. So it can just become a much larger problem than it might have otherwise been.
So at the beginning we talked about this soil contamination. So when a water breaks, a main water pipe breaks, then a lot of soil goes into this situation, obviously, because potentially very, very likely because of the amount of water that sits around and how it makes all these soil fly literally or swim into the water pipe. So what is the relationship or the correlation between the soil and then the bacteria or the sewage? Because I think that it's so important to understand that we're testing sewage water after a main break.
Yeah, so when water has contact with soil, it becomes classified as Category 3 black water. And what that means is it's treated essentially as sewage water. Sewage bacteria are naturally occurring. They're in the soil. You know, unless you're going outside and eating a bunch of dirt, it's generally not a problem. My toddler's eaten their fair share of dirt. So listen, it happens. But that being said, when that naturally occurring bacteria ends up in the soil and then that soil ends up in the water, that can lead to problems because then that's something that is intended for human ingestion.
Okay. So let's go ahead and finish this quick podcast with some recommendations, mostly for homeowners or building owners that want to test these two things, both the coliforms and then the lead, and then actually saying a little bit of summary from all these little bottles that you have.
Yeah. So call your expert. Call your professional that's going to help you design that water sampling plan and that's going to help you figure out what exact concerns you may have, how to sample for them, how to get them analyzed, where to get them analyzed, and then help you figure out what to do with those results when you've got them. Because it's easy to say, well, my number's 15, now what?
Okay.
So
is 15 a good number?
It depends on what you're looking at.
Okay.
So, you may be looking for Legionella. You may be looking for, pH, total suspended solids. You might be looking at lead or copper, other metals. It just depends on what it is that you're trying to identify. Is it present in my building or not?
So let's put this over here. This. So these are the two that we think could be the most important for homeowners. One is coliforms, and then the other one is lead or minerals. These two for homeowners, at least after this main break, which affected thousands and thousands of people. And then for, I'm going to call it non-potable water because they're not drinking the water from the chillers. But this is also recommended to protect the equipment and then the health of the people surrounding this.
Yeah, I mean, Legionella, you can also take the water sample, but if you're seeing a slime buildup on any area of your machinery or at your building, that's when you might want to be testing with the swab.
In the last question for professionals. Is this involved or included in any of the environmental impact statements or any of these?
I wish it was.
Oh, so it's no. So, because sometimes when we do these things, we talk about sound, we talk about smells, and we don't talk about the potential contamination through evaporation of these little micro droplets.
Yeah, I mean, the thing is, there are certain lenders or programs out there like the Small Business Administration that does require testing of your drinking water. So for instance, the SBA, they do lending for daycares and they require lead in drinking water at the daycare. It's fantastic. We found a lot of problems and protected a lot of kids by doing that. It's a great program.
That's the reason why you do this job and I do this job.
But that being said, no, normally there is no requirement. You know, people go in, they buy buildings, they renovate them, they rehab them, they're fantastic, they're beautiful, but nobody ever looks in the pipes because why would you? It's just, as long as the water's flowing, it's fine. But
I see when I do remediation, like today, I still remove asbestos insulation from water pipes. And this hasn't been used for 50, 60, 70 years. So the pipe is obviously the same pipe that has been over there for 70 years or so. In another discussion, we talked about that it probably should be some sort of cutoff point where you need to either test or replace your pipes.
yeah, but nothing like that exists right now, as long as the pipe's intact. Even if it's not intact. I mean, we have tons of leaking pipes out there. But no, there's no, required testing unless you're a municipal water supplier.
Thank you very much for this talk. I think that is a lot about water, and there is a lot more information out there, and at least we have a few tests that could help a lot of people. Thank you very much, Corey.
You're welcome.
Yeah.